So graphing y equals 1/3 to the x. You see that it's an exponential one. The base is 1/3. This is a basic parent graph. And so all you're going to need to do is you're going to need to make sure you have your asymptote at y equals 0. You know that your graph is going to go through 0, 1. And when you plug in 1, you get 1, 1/3. So it swoops down like this, approaches your asymptote, and goes up like that. So any exponential graph, you'll label those 2 points, always 0, 1, and 1, whatever the base is. You'll always have an asymptote at y equals 0. And then that would be your parent graph, and if there were other transformations, you would do that from there. And we'll look at some of those today. What happens to y when x gets increased by 1? Well, all that y is going to be is y is going to get multiplied by 1/3. So each time you go up by 1, for example, if we labeled this point, you'd get 2, 1/9. You would just multiply the previous value by 1/3. Is this function increasing or decreasing? So that's going from left to right. It is decreasing. The intercepts, there are no x-intercept, but the y-intercept is at y equals 1. Does it have an asymptote? Yes, it does. Y equals 0. Some students wonder, since it's swooping up, is there a vertical asymptote? No, because the only time you would have a vertical asymptote is if there was an x value that would be a non-permissible value. And you can put any x you'd like in for an exponent, positive or negative number, no matter how big or how small. The domain of the function then is everything. The range of the function, y has to be bigger than 0, or if you write it in interval notation, it would be from 0 to infinity. So for straightforward graphing ones in the homework, you can try 3, 5, and 7.